With Chapter A, Stulz on credit risk and credit derivatives, we go back to, again, in the Stulz text, frankly, not a lot of imagination here because he's constantly going back to and inheriting the Merton model, right? So that simple Merton model treats the firm in a two-class structure with equity and debt. So this is the right-hand side of the balance sheet, so to speak, and you'll recall that the central insight of the Merton is treat equity as a call option on the firm's assets. That is to say, if the shareholders pay off all of the debt, so i.e. exercise their strike price, they will own the firm's assets. And so the additional tweak here is to add a third class, subordinated debt. So now we have senior debt, right? So this senior debt has the senior claim on the firm's assets, then subordinated debt, or we could call this junior debt here, and then finally equity would be last in line or bottom of the totem pole or residual claim. If there's nothing left over for equity, it gets wiped out. On the other hand, equity has all of the upside leverage. And so now the value of the firm, and similarly, if this is the right-hand side, this is the capital structure, we say the value of the firm is the sum of the senior debt, the subordinated debt, and the equity. Stulz uses a simple formula here to derive the spread on a credit. So we can think about a bond. And this is useful to me, not because it's realistic. I do not think it's realistic, but much of Stulz is not realistic. It's useful rather because it gives us a chance to exercise a basic building block, that is to say, continuous discounting. So the formula in Stulz is here at the bottom. I think it's just instructive for us to be able to derive it. I myself don't memorize it so much as I'll just use this and sort of process this in my head because we don't need any new information for this. What he has here is the price or value of risky debt denoted with a D. F is the face value of that debt. And you'll notice what we have here is the value of a zero coupon bond discounted continuously at a yield equal to R plus S. So you recognize that. If we have a $100 bond, we discount it continuously at this yield, we get today's price of a zero coupon bond. The only thing is now the yield, instead of a single yield, is broken into two pieces. It's the risk-free rate plus the spread. And so this is, if we divide both sides by the face value of the debt, and then we isolate here, we have the exponential on the right. We know we can take the natural log of both sides and then solve out for the spread. And we see here the spread as a function of the time to maturity or maturity of the zero coupon bond and the natural log of the ratio between the price of the debt and the face value of the debt. So the idea here is if we observe the price of a bond, it's going to be less than the face value, and we know that's maturity and we have a risk-free right, we can impute what that price says must be the spread. So that's the formula that Stulz shows, and we have seen that at least in a sample question. Not so sure about the actual